Okay, so this is Unit 1, Lesson 2. This is the last video for this lesson, and we are going to construct the angle bisector of angle BAC, provided below, and label the angle bisector AG. So the first thing you want to do is put your compass point on the vertex. The vertex is at A. Doesn't matter how much you open your compass by. The important thing, again, since this is the angle, is that it intersects both rays of the angle. So we've drawn an arc that intersects both rays. The reason that's important is we want 2 points that are the same distance away from that vertex. So we know this segment and this segment are congruent. So technically, we kind of have a segment here between these 2 points that we're now going to bisect. So I'm going to transfer my compass to the first point of intersection that we've made between the arc and the ray. And you can adjust your compass if you'd like, or you don't have to. I'm going to make an arc. Without adjusting the compass from the first arc that's in purple, we're going to make an arc that is the same. So basically the radii of these 2 arcs are the same. Where the 2 arcs intersect, we can put a point. Sorry. There's my point. Lovely. And through any 2 points, we can put a ray or a line. So this is going to extend from the vertex through the point where the intersection of those 2 arcs are. And it told us to label that G. So from A through G is our ray that bisects this angle. So we do know that this piece of the angle is congruent to this piece of the angle because an angle bisector divides this entire angle into 2 congruent halves. So we're going to do this again. Let me bring my compass down to practice the concept. So using a compass and a ruler, also called the straight edge, we're going to construct the angle bisector. On the New York State geometry regions, there is no protractor. So you could just draw a line and estimate, however, that will score you no points. Okay, so we put our compass point on the vertex of the angle, and we make an arc that intersects both rays of the angle. Here's a point equidistant or the same distance from the vertex. We know this because these are both radii of the same circle. I'm going to move my compass to the first point of intersection of the arc and the ray, and I'm going to make another arc. I'll move my compass to the second intersection between the arc and the ray, and I make another arc. Where those 2 arcs intersect, I can put a point. And through any 2 points, I can draw a line, or a ray in this case, since this is an endpoint and this does extend through infinity, if I put an arrow on it. Otherwise, it's just a segment. So if I call this A, call this point B, call this point C, and call this point D, we know that the measure, which M stands for, of angle ABC is equal to 2 times the measure of angle ABD. Okay? It is also equal to 2 times the measure of angle DC, which is the other side. Okay? Because we know this angle is congruent to this angle. Another way of labeling the angles is, again, you can label this as 1 and 2. So we do know that angle 1 is congruent to angle 2 because these 2 halves of the angle ABC are congruent to one another. All right, we're going to construct the angle bisector one more time to conclude this lesson. If you would like to pause and try this on your own, and then make sure you did it right so that you know you got this process down, please feel free. Otherwise, keep watching and we're going to go right through it here. So I make an arc through both rays of the angle. The compass point is at the vertex. I transfer my compass, different color here, perfect, to one of those points of intersection and make an arc. I'll transfer my compass to the other point of intersection, again without adjusting the width of the compass, and make a second arc. Where those two second arcs, or red arcs in this case, intersect, I can put a point. And through any 2 points, one being the vertex and one being the point of intersection I just created, I can draw a line. And again, we have an angle bisector.